Good morning to all of you. This is Mova Prasad signing into DCB Suryapat live channel. Already we are in the 9th topic, tangents and secants. So we comes to an end in the exercise number 9.2. Pratap Reddy sir is giving a total details about our tangents and secants, which are explained detailedly by basic concepts and theorems, constructions, and if the how to draw the tangents from a external point, and important concepts along with the projects and examples also, which is given to you, and some of the homework parts is also given to you, and generating new sums also will be discussed by our Pratap sir. Sir, Pratap sir, please, this is the time for you to start the lesson.
Good morning, everyone. Children, now we are in last concepts of the topic tangents and secants to a circle. We have to discuss only one exercise, that is 9.3. Now the topic to be discussed is segment of a circle formed by a secant. Segment of a circle by a secant. What is segment of a circle? For example, if we cut an apple fruit by a knife, it can be first, if we cut at middle or whatever the portion, if we cut with knife, apple fruit can be divided into first two parts. Okay, if you cut any fruit into two parts, then it can be divided by a knife. In the same way, if a circle is divided by a line, is known as a secant, then it can be divided into two parts. It can be divided into two parts. That we have to discuss here. Okay, let us know the concepts about segment of a circle, and we have to find the areas of the parts. If a line intersects the circle, then we know that it is a secant. It is divided. It divides the circle into two parts. It divides the circle into two parts. Now we have to find the areas of the two parts. Okay. I am drawing a circle and also another circle. Same radius or different radius, no problem, whatever the radius. I am drawing two circles. Okay, with center O. Now, if a line intersects the circle somewhere on the circle, if we draw a line like this, okay, call the line as L, the circle as C. Circle is C. No problem. Here, a line L intersecting the circle in two distinct points. Say A and B. Say are named then as A and B. That means two common points of the circle and a line. That means here the line is already we know the definition of a secant. L should be a secant since it intersects the circle in two distinct points. AB chord forms. Okay. The line, what is happening if a line intersecting a circle? Then what happens? The circle divided into two parts. Okay, this is one part, lower part. This is upper part, another part. Okay. Now, if we shade this lower part vertically, or designed or shaded. Vertically. Okay. This part A, B, some here if you put P here, A, P, B, A, the region A, P, B, A is known as, this is small, okay? This is small, this part is small, this part is large. Comparatively, this part is, lower part is small and upper part is bigger or larger. Therefore, this small part, A, P, B, A is known as minor segment of the circle. That means, which is small, it is known as minor segment of a circle. Next, the upper part. If we shade upper part with vertical lines, horizontal lines, shade in different way. Already we shaded lower part vertical. This can be shaded as horizontal. Okay. What we have shaded upper part. This is larger part of the circle. Whenever line divides the circle into two parts, this upper part or upper region is known as major segment of the circle. Is it clear? This is known as minor segment of the circle. This is known as major segment. Of the circle. Whenever a given circle divided into two parts. Okay. Is it clear? Whenever a line intersects the circle and somewhere, the smaller portion or smaller region is known as minor segment, and a larger region larger portion is known as major segment of the circle. These are the segments of a circle if a line divides the circle. Okay. Next, is there only this type of segments or another type of segments is there? Just think. Here, the line intersecting somewhere in lower portion, in upper portion. If it divides it upper portion, then minor segment can be formed upper side above the line. Major segment can be formed below the line. If it intersects here. Okay. Next, what happens if a line intersects at the center? Just think, what happens if a line intersects at the center? Now, we are dividing a circle by a line at the center. At the center. Okay. This is a line, whatever it may be. It may be called as M. This is the center. Now, what happened? The circle is divided into two. Is there any minor segment or major segment? If there exists any smaller region comparatively? These are regions formed if a line intersects a circle. Okay, just think what happened? The line divides the circle at the center, then the circle can be divided into two equal parts. Two equal parts. Since the line intersects at the center. At the center. That means these two portions are same. These two regions or these two segments are same. Okay. If we shade anyone, upper portion or lower portion, if we shade vertically or design vertically, okay. What is this? What is this lower portion and what is this upper portion of the circle? Do you know? There is a word. This is half of the circle. Exactly half of the circle. That means this represents, just see here. This represents a semicircle. Half of the circle, exactly half of the circle means it is a semicircle, right? This is a semicircle. The upper portion is also a semicircle. Those two are equal regions. Therefore, area, if we find area of the semicircle, just this is not important in our syllabus, but we have to know the concept. Okay. If we have to find the area of a semicircle, this portion, lower portion or upper portion, just simply what is the area of the circle? It is pi r square. What is the area of the circle? It is pi r square. The formula is pi r square. If to find half portion or area of the semicircle, means if it is divided by 2, pi r square by 2, then it is the area of the shaded region or area of the semicircle. That's all. Okay, it's clear. If to find area of the semicircle, just take pi r square by 2, substitute radius value, given radius, then you will get the answer. That's why this is not important in our syllabus. Okay, if asked in examination, if it will ask in examination, then you can solve by using this formula. Okay, now this is only very important. This is only very important to find minor area of the minor and major segments. That is very important. Okay, right. Now let us discuss the problems given in exercise 9.3. There are two types. Exercise 9.3. Okay. First problem. I am reading first problem. Just I am reading. Just listen. In a circle of radius 10 centimeters, given that radius of the circle is given as 10 centimeters. Okay. In a circle of radius 10 centimeters, a chord subtends a right angle. Subtends a right angle at the center. Find the area of the corresponding minor segment, also major segment. We have to find the areas of minor segment and major segment, which we have discussed earlier. Okay. Use pi equal to 3.14. Just use pi equal to 3.14. It is approximate value 22/7. I will explain about pi value. Pi and E are irrational numbers. Just know pi and E are irrational. Pi and E are irrational. E is exponential constant. This value is 2.718 approximately. Next, pi value is also irrational. Those two are not rational because they are neither terminating nor recurring. Neither terminating nor recurring. Therefore, they are irrational numbers. Those are not rational numbers. Okay. Pi value lies between 21/7 and 23/7. Pi lies between 21/7 and 23/7. But we are taking pi value as, in general, we are taking 22/7 in so many problems or so many ways. So many times. We are taking pi as 22/7. This is not exact value. Just remember, 22/7 is not the exact value of pi. If it is exact value, then it represents a rational number. 22/7 is a rational number. It is in the form of p by q. P and q are integers. Q not equal to 0. Therefore, it is rational. Then this should be rational. But pi is irrational. That's why 22/7 is not an exact value. This is also approximate value. Approximate value. Is it clear? 22/7 is also approximate value. Since it lies between 21/7 and 23/7, we are taking average of these two as 22/7. This is also approximate value of pi. Just remember. If we take in decimal form, we can take 3.14 or 3.1416. 3.1416 up to that we are taking. Okay. Now, going to our present problem. Now we are here. We have to use pi equal 3.14, but not 22/7. Okay. Minor segment and area of the minor segment and major segment. Now I am drawing a circle. I am drawing a circle. Okay. Next. This is the center. O. This is the center. O. And the radius is given as 10 centimeters. And a chord subtends a right angle. A chord subtends a right angle at the center. At the center. We can draw roughly. Okay, this is the chord AB. Okay, AB is a chord. AB is a chord of the circle. Of the circle. This chord subtends a right angle at the center. Subtends means making an angle. making an angle. Making an angle, a right angle. Put right angle symbol here. Then right angle triangle AOB forms. Okay, right angle triangle AOB forms. Now, segments means parts of the circle. We have to find minor segment and area of the major segment. Okay. If this card is dividing the circle into two parts or two segments. One is this, just share this portion or region. Okay, this is the lower portion. Okay, this is the minor segment. If you put here some point P on this arc AB, if you put some point P, then APBA portion or region or some part of the circle is known as minor segment. This is minor segment of the circle. We have to find the area of the minor segment. Okay, for that, after finding area of the minor segment, we have to find area of the major segment. Already we have discussed it earlier. Okay, the remaining portion, if you cut this lower portion, then remaining portion above the card, the circle, the part of the circle above the card AB is known as major segment. This is the major segment. This is the minor segment. Okay, this is the minor segment. This is the major segment. We have to find areas of these two segments. Okay. For that purpose, what is here? A triangle is here. Next, OAPBO. What is this? It is a, if we cut OAPBO, it is one part of the circle, total part of the circle with center O. Okay, this is called as, known as these two radii. Okay, with two radii and one arc length. Okay, this is known as a sector. OAPB is a sector. We have to find area of total sector. Angle here, angles AOB equal to 90 degrees. This is given in the problem. Okay, card substance that makes an angle at the center is 90 degrees perpendicular. Okay, now first we have to find the area of the sector. Then we will get the area of this part, minor segment. If area of the triangle AOB is subtracted from total area of the sector, we will get the area of the minor segment. Okay, area of the minor segment. Now I am writing the formula. Area of the minor segment. APB equal to area. AR means area. Area of the sector. OAPB. If we mention O also, OAPBO, that is the sector, minus area of the triangle, right angle triangle. Here it is right triangle. Area of the right triangle AOB. 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 Is it clear? To get area of this minor portion or minor segment, area of the sector minus area of the triangle. If we subtract this triangle area, we will get lower portion. That is required area of the minor segment. That's all. Okay, what is the formula of area of the sector? Formula is x by 360 degrees into pi r square minus area of the triangle. Here it is right angle triangle. OA equal to 10 centimeters. OB is also 10 centimeters. This is radius already given in the problem. R equal to 10 centimeters. Therefore, area of the right triangle. One is base and another is height. These two are perpendicular sides. Perpendicular to each other. OA and OB. Therefore, if we take OA as base, then OB will be the height or altitude. That's why I'm writing half into base into height formula. I'm writing the formula. This is area of the sector. What is x? This is x. Sector angle. That is called sector angle. Here x equal to 90 degrees. Already we know x equal to 90 degrees. Okay. Now substituting the values, x means 90 degrees by 360 into pi value 3.14 into r square. What is r? 10 into 10 minus half into, just write in parenthesis, small brackets, half into, what is the base? Base is 10 centimeters. Here b equal to 10 centimeters and height equal to 10 centimeters. B equal to 10, height equal to 10. Okay, 10 into 10. Okay, is it clear? Now simplify 0, 0. R square means R into R square means R into R. R is 10, 10, 10. Here for triangle, base and height value we have substituted. Now 0, 0, 9 1s are 9, 9 4s are 36. Okay, 2 2s are 4, 2 5s are 10. 2 2s are 4, 2 5s are 10. Again 2 1s are 2, 2 5s are 10. Okay, now here 2 1s are 2, 2 5s are 10. Now what is the value? 3.14 into 5 into 5, 25 minus 10 into 5, 50. 10 into 5, 50. Okay, here remaining factors 3.14 into 5 into 5, 25 minus 10 into 5, 50. Now 3.14 into 25. What is the value of 314 into 25? 25 4 is 100. 25 1 is 25 plus 10, 35. 25 3 is 75. 75 plus 3, 78. 7,850. 7,850. But here is a decimal place. How many places are there? 1 and 2. 2 places are, 2 decimal places are there. Now we have to put decimal point 2 places, before 2 places. Then it becomes 78.50 minus 50 equal to 78.50 minus 50. What is the value? Equal to 28.50 or 5 centimeter square. 20 meter square. Since this is the area of the area means centimeter into centimeter square or square centimeter. Okay, this is the area of the minor segment. Just note down, area of the minor segment equal to 28.5 centimeter square. Just note. We found area of the minor segment. This is the first bit. This is the first bit given to find area of the minor segment. I will explain again. Area of the minor segment equal to area of the total sector minus area of this triangle, right triangle. Then we will get the area of the minor segment. That's why I am writing the formulas of a sector and area of a triangle. I am substituting the variable values and simplify it. After simplification, we are getting 28.5 centimeters square. That is the area of the minor segment, the shaded portion. Now, second bit. Going to solve second bit. Area of the major segment. Area of the, we have to find area of the major portion or major segment. Above the chord AB. Above the chord AB. The portion of the circle above the chord AB. That is the major segment. Area of the major segment. If we put a point here Q, if we put a point Q here, then A, B, Q, A. A, B, Q, A. This is the area of the major segment. A, B, Q, A. Now, how to get area of the major segment? How to get area of the major segment? This portion. Already we found area of the minor segment. Now, if we find area of the circle, then subtract from area of the circle, subtract the area of the minor segment. Just cut it. Cut this portion. Cut this lower portion. We will get area of the major segment. Okay? That's all. That means area of the major segment ABQA equal to area of the circle, total circle, area of the circle minus area of the minor segment APBA. That's all. Okay. Now, what is the formula to find area of a circle? It is pi r square by pi r square. It is pi r square. Area of a circle is pi r square. Formula, I am writing the formula, minus area of the minor segment of the circle. Already we found it is 28.5. Already minor segment area of the 5 centimeters area. 28.5 centimeters square. Okay. If we subtract area of the minor segment from total area of the circle, if we subtract area of the minor segment from total area of the circle, we will get upper portion of AB, that is area of the major segment. Now, pi value 3.14 given into r square. What is r square? 10 square. Or 10 into 10. Or 10 into 10 minus 28.5. Okay, pi r square. R is 10. 10 into 10 minus 28.5. Okay, now 3.14. 10 into 10. 100 minus 28.5. Okay, now multiply 314 with 100. We are getting 31400. 31400. Okay, 31,400. But there are two decimal places here. That's why we are putting decimal point here. Before two decimal places. Before two places. From right to left. Okay, minus 28.5. 314 minus 28.5. Okay. 314. Subtract 28.5 from 314. Only 1 0 is needed. This is not needed. 5, 3. 3 means 13 minus 8. 5, again 5, 13 minus 8, 5. Here 0, 10 minus 2, 8. Here 2, 285.5. This is 285. 285.5 centimeter square. This is the area of the major segment. Just note down. In this way, we have to find area of minor segment and also area of the major segment. If a card divides the given circle into two parts, area of the major segment, here area equal to, we are getting area equal to 285.5 centimeters square. That's all. In this way, we have to find area of a minor and major segments of given circle. This is one method. This is one method. If the sector angle is 90 degrees, the first method is if the sector angle is 90 degrees. This is the first method. Everywhere, no need to give 90 degrees. If it is given that other than 90 degrees, means if sector angle is 60 degrees, if sector angle is 100 degrees, if sector angle is 120 degrees, then what to do? How to find area of a minor segment and major segment of a circle? That let us discuss in second problem. Okay, going to solve second problem. Okay, going to solve second problem. Next, I am reading the second problem. In a circle of radius 12 centimeters, in a circle of radius 12 centimeters, a card subtends an angle of 120 degrees. A card subtends an angle of 120 degrees. Again, I am drawing a circle. But here, the sector angle is, what is given? Radius is 12 centimeters and a card subtends an angle of 120 degrees at the center. That means sector angle is given that 120 degrees. 120 degrees.
సార్ సార్ ప్రతాప్ సార్
Sir,
లెటర్స్ కొద్దిగా పెద్దగా అట కొంచెం విజిబిలిటీ లేదని పిల్లలు కొంచెం కామెంట్ చేస్తున్నారు. కొంచెం పెద్దగా చూడండి లెటర్స్. ఓకే సార్.
circular, sir.
లెటర్స్ బోర్డు మీద లెటర్స్.
Letters. Okay, sir. Okay.
ఇట్స్ ఓకే సార్. థాంక్యూ.
I will write in big size.
ఓకే సార్. రైట్ సార్. ప్లీజ్ బెస్ట్.
Just see here, all of you see here, center, this is the point A, this is the point B, this is join AB. Okay. AB is a card. AB is a card. Subtends 120 degrees at the center. Means this angle. This angle is 120 degrees. This angle is 120 degrees. Okay. AB is a card. OA and OB are radii. That is given that 12 centimeters. Okay. Now draw perpendicular from O to the card AB. Draw perpendicular. This is perpendicular. This is also perpendicular. This is not visible, but please understand the problem. Okay. Let this point here. Let it be P. Let it be P. OP. Now, what is the minor segment and what is the major segment? No doubt. The card AB divides the circle into two parts. One part is like this, shaded portion. And the other part is above AB. Below center. This part is below center, means minor segment. Smaller. This is smaller, this is larger portion. Okay, below AB, this is smaller. Above AB, the region is larger than lower portion. That's why this is the minor segment. Minor segment. This is the major segment. Major segment. This is the minor segment and this is major segment. We have to find the areas of these two regions, these two segments of the circle. To find area of these two segments, let a point here as X, let a point here as Y. On the circle below, take a point X, above take a point Y on the circle. Now, what is the sector here? OAXBO. OAXBO. Two radii and one arc length. One arc length is a sector. What is the minor segment? AXBA. One arc length, one arc and chord AB. Between the chord AB and this arc AXB is the minor segment. To find what he asked, find the area of the corresponding minor segment of the circle. Only minor segment. We have to find area of the minor segment only. No need to find area of the major segment given in the problem, asked in the problem. Okay. What to be used? Pi equal to 3.14. Pi equal to 3.14 and root 3 equal to 1.732. Root 3 value is also used 1.73. These values to be used in the problem. Okay. Now, to find area of the minor segment, first we have to find area of the sector. Okay. Now, area of the sector. OAXBO. What is the formula? X by 360 into pi r square. Formula to find area of a sector. X by 360 into pi r square. Already sector angle is given as 120 degrees. That's why 120 by 360 into pi. Pi can be used as 3.14. Okay, 3.14 and r square. What is r? It is 12. 12 into 12. R square means 12 into 12. R into r. Now 0 0 gets cancelled. 12 1s are 12 3s are 36. Next 3 1s are 3 4s are 12. The remaining factors are 3.14 into 12 for the 48. 12 for the 48. 3.14 into 12 for the 48. Now multiply 314 with 48. 8 for the 32. 8 3 11. 8 3. 8 is the 24 plus 1 25. 4 4 the 16. 4 1 the 4 plus 1 5. 4 3 the 12. 2 7 10 5 1. 150 72. 150 72. 2 decimal places. 150.72 centimeter square. 150.72 centimeter square. This is the area of the sector OAXBO. To find area of the minor segment, we have to subtract the area of the triangle AOB. We have to subtract the area of the triangle AOB triangle. If we subtract the area of the triangle from the sector, we will get area of the minor segment. For that purpose, now we have to find out area of the triangle AOB. Area of the triangle AOB. Just note down here. Area of the sector. Already we got area of the sector equal to 150.72. I'm writing in big way. 72 centimeter square. This is the area of the sector. Now, to find area of the triangle, for that purpose, here this is the different way from previous one. Why this is different? In previous problem, the sector angle is given as 90 degrees. The sector angle is given as 90 degrees. 90 degrees means already we know base and radius both are equivalent to radius. In previous problem, both are equivalent to radius. Already we know base and radius, base and height. But here the angle is not 90 degrees, other than 90 degrees. This is different from previous one. It is given that 120 degrees. We don't know the base, that means AB. We don't know the length of AB. We don't know the angle OP, height of the triangle OP. We don't know the height of the triangle OP. Okay, we have to find out. Base AB and height OP of the triangle OAP. Just consider triangle AOB. This to be considered. We have to find the area of this triangle. For that purpose, we are using, again, this problem comes under connection. We are using trigonometric ratios. Since OAP is a perpendicular triangle, OPB is also a perpendicular triangle. Again, these two are congruent. Already we know that. Again, OP divides the line segment into two equal parts. Already we proved OP, the radius, the perpendicular OP divides AB into two equal parts. That means AP equal to PB, AP equal to PB. Already we know that. Again, this is the bisector of angle. OP is the bisector 120 degrees. Bisector of this sector angle. Bisector means 120 is divided into two equal parts. One is 60 degrees, other is also 60 degrees. That's why this is 60 degrees. This is 60 degrees. This angle is 60 degrees. This is 90 degrees. This is 60 degrees. 90 plus 60, 150. How much this is? This is 30 degrees. This can be 30 degrees. 30 degrees. Okay, this is 30, this is 60, this is 90. In right triangle, AOP, in right triangle AOP, Okay, angle OAP equal to 30 degrees. Since angle angle OAP equal to 30 degrees, angle AOP equal to 60 degrees. Angle AOP equal to 60 degrees. Since this is divided into two equal parts, that is this 60. That means 60 plus 90. These two are complementary. 90 degrees. That's why this is 30 degrees. Now we are using angle A. Angle A means 30 degrees. Angle A means 30 degrees. Sin 30 degrees. Sin 30 degrees equal to sin 30 degrees equal to, in right triangle OAP, opposite side to angle A. Opposite side to angle A. What is the opposite side? It is OP. It is OP by hypotenuse. What is the hypotenuse? OA. OA and OB are hypotenuse. OA. Is it clear? In right triangle AOP, sin A. A means here A is 30 degrees. Sin 30 degrees equal to opposite side to angle A. Opposite side to angle A is OP. Hypotenuse. Hypotenuse is OA. OA. That's a sin 30 value 1/2 equal to OP by what is OA? It is equivalent to radius. Equal to radius 12. Implies OP 2 into OP. 2 into OP equal to 12 into 1. 12 by cross multiplication. 2 into OP. 2 into OP equal to 12 into 1. 12 into 1. 12. Or OP equal to 12 by 2. 2 1 to 6 equal to 6. OP equal to, therefore, OP equal to 6 centimeters. OP equal to 6 centimeters. Note down. OP means height. OP means height of the triangle. OP is the height of the triangle. That means we got height of the triangle. We got height of the triangle. Here I am writing height equal to 6 centimeters. That is OP. That is OP. Next. Okay, note down. I am erasing this matter due to space. Okay. Next. To find base AB, if we find AP, then double of AP becomes AB. AP is the half of AB. AP is the half of the distance AB. That's why if we find AP, then we will get AB. Okay. Now to find AP is which side? Which side in the right triangle? This is the adjacent side to angle A. AP is the adjacent side to angle A. Adjacent side means which trigonometric ratio is used? Right. Cos A equal to, in right triangle AOP cos A equal to, I am using trigonometric ratio cosine. Cos A equal to adjacent side to angle A. Adjacent side to angle A is AP. AP is the adjacent side to angle A by hypotenuse. Hypotenuse is same, OA. As previous, it is same, OA. Now, cos A means cos 30 degrees. What is A? It is 30 degrees. Cos 30 degrees equal to AP by OA. OA is 12. OA is 12. Now, okay, cos 30. What is the value of cos 30? It is root 3 by 2. It is root 3 by 2. Next, AP to find out, AP to be find out by 12. Or 2 into AP equal to 12 root 3 equal to 12 root 3. By cross multiplication, 2 into AP equal to 12 into root 3. Okay. Now, AP equal to 12 root 3. 12 into root 3 value 1.732. Use root 3 value as 1.732 is given in the problem by 2. If we transpose 2 to the right side, then it goes to denominator, 2 goes to denominator. Since it is in numerator of left hand side, that's why it goes to denominator. Now simplify. 2 ones are 2 6 are 12. 6 into 1.732. 1.732. Okay.
For 9:56 AM, sir, time.
Okay, sir. I am writing the value, sir. Now. Okay, sir. I will continue in next class, sir. Okay, note down here. This is AP. I will continue in next class. I will complete this problem in next class. Already we found height and this V, AP becomes half of the chord. If we double the AP, then we will get AB. That means base. In that way, we can find area of the triangle. That's all. Okay, sir?
Thank you very much, sir. You have given the complete concept of secant and the questions based on problems based on secants in exercise 9.3. It has given already, and the remaining part will be continued by Pratap Reddy sir tomorrow at 9 o'clock. See you. Thank you for the technical team to support the live streaming.